Good afternoon, Internet. I am Matt Buyak, and in this video, we'll be doing a little bit of work on our big integer class. Now, I know in the last video I said we would be moving on to problem number 54, but I decided I want to make a little bit of a longer video for that problem, and so that will be coming out in a few days. Looking ahead to problems 55 and 56, I was thinking that it would be really nice to have some additional functionality in our big integer class. Now, I've already done 3 videos on this code, but we're only adding new functionality as we need it. Otherwise, I probably would have put out a dozen big integer videos and everyone would be sick of them. You'll notice in particular that we don't have the ability to multiply a big integer by another big integer. We can only multiply a big integer by a 32-bit integer. But that's not the functionality we're going to be adding today. What we're going to be working on today is actually fairly non-technical. We're just going to be adding the ability to initialize a big integer from a string and to convert a big integer back to a string. This is going to make working with big integers in general much more easy. And so let's get into it. So let's start by adding the declarations for the new functionality that we would like. So as I said, we want to be able to initialize our big integer from a string. So we're going to say const string reference digits. We'll need to include string up here at the top. And then we also want the ability to convert our big integer to a string. And so we'll say down here, std string to string const. Okay, so now let's take this declaration and open up our implementation. And we're going to add that just right here. Okay, I'll say BigInt. And we want to start by calling the default constructor. So just to initialize it to 0. And then we're going to iterate over the strings in, or excuse me, the characters in the string and build up our big integer. So let's say for char ch in digits. We're going to say multiply by 10 and add ch minus 0. Okay, so each time we multiply by 10, that's just going to shift the digits to the left to make space for a new digit. And then we're just calling add here to add that new digit. You'll notice that as we iterate over the digits in the string, we're going to be adding them from most significant to least significant just as we would like. Okay. Now, there is one thing I would like to add to this implementation that will probably save us some headaches down the line. And that is to deal with the case when our string contains some non-numeric characters. As our code is currently written, this will happily subtract the character code for 0 from whatever character is in the string and have purely unexpected behavior if the character is not a digit. And we would much rather have it just stop immediately if we get to that case. And so what we're going to do is something I think I've actually never done before. We're going to throw an exception. This is exactly what would happen if you called, for example, s to I or something like that, converting from a string to an integer. This is the exception that would be thrown. I've never been a huge fan of exceptions in production code. They always seem quite awkward to use. But I think this is the perfect case for it. And so that's what we're going to do. So we'll say, well, first we need to include std except. So let's go up top here and say include std except. And then down here, as we're scanning over the digits, we'll say if not is digit ch. And then we'll just say throw std invalid argument. And this takes a string describing the nature of the failure. So we can say throw invalid argument. And then we'll just say non-numeric character in BigInt initialization. And I think that is all we need. Okay, so that should be everything we need for initializing our BigInt from a string. So now let's go back to our header file and grab the other function that we would like to implement. It's going to go down here. I always like to make sure that my the order of my functions in my CPP file matches the order that they're declared in my header file. Just a stylistic thing. Okay. All right, so there's only one. Actually, I guess you could say there's a couple of gotchas, perhaps in this implementation. The first is that if our big integer is 0, we still want to return a string. We don't want to return. We don't want it to return the empty string. We want to return a string that has 0 in it, the digit. And so let's say if I think it's. Let me actually check. I think there's just a function here. Yes, we can just easily check if our big integer is 0. So we'll say if 0 return std string 0. Okay. The next thing we'll do, let's declare a string here called digits, which we're going to fill with the digits of our integer. And we'll say while not 0, we'll say digits dot push back. I think it's divmod. Yeah, so we have this function here, divmod, that both divides by a 32-bit integer and also returns the remainder. And so we can say divmod, we're going to divide by 10 and return the remainder. And we're going to push that onto our string as a character. So we have to be sure to add the character code for 0. Let's convert this to a character to make the compiler happy. Okay, and we should be good. Except if you read this carefully, you'll notice that we're pushing the digits in the wrong order. That is, we're going to start by adding the first remainder when dividing by 10 as the most significant digit in our string, rather than the other way around. And so after we have constructed our string, it's actually going to be backwards. And in order to reverse it, we'll need a little function from algorithm. And so then we'll just say reverse, and we'll say digits.begin, digits.end, and then we can say return digits. Okay, that should be good. And so you may think that now we're done, right? No. Now we get to write some tests. I know everyone's favorite subject tends to be a little bit dry, but if we're going to be serious about updating our library here, we should write some tests. So let's go to our tests directory and open up BigInt test.cpp. We don't have to do anything fancy here. As you'll recall, we basically just have a series of functions that we call or checks that we make, and if any particular test fails, it will print out the details of that failure, and then we say go to end and skip over this success. Otherwise, we'll get to the end and print out success. So we'll want to add a new set of tests here. So we'll say if not test BigInt BigInt to string. Go to end. As a quick aside, this is one of the what I consider the acceptable uses of go-to is basically if there's some end code that you have to, something has gone wrong and you have to skip to the end of your function. Usually go-to is to be avoided, but this is one of the few situations where I think it's appropriate. Okay. So now let's go up right here. Okay, so there are a couple of different cases that we might want to test. I think the most straightforward is to just initialize a big integer with a string and then convert it back and see that they match. So let's say BigInt, we'll call it small big because it's not going to be that big. This is going to be in contrast. In a moment, I'll have one that's a little bit bigger, which is going to be, I don't know, large big or big or something like that. But so we'll say small big, 1, 2, 3, 4, 5. And then we want to say std string small big digits. And we'll say that's going to be equal to small big dot to string, and then we'll say if not small big digits equals 1, 2, 3, 4, 5. Excuse me. We can if not equal to. I suppose that construction probably works as well. Not equals, but it's stylistically weird. Okay, then we'll say printf failure. Let's see, unexpected value converting BigInt to string. And return false. Okay, so that's a basic test. Now I want to try a case where we initialize, rather than using both the initialization with string and converting from string, using both of our new functions. We're going to use one of the old initialization functions and then convert to a string. So if we take a look at BigInt, you'll see that we have this initializer list function, constructor, which is a little bit awkward to use, but it's nice when we want to just shove raw values directly into the big integer. And each of these values is going to make up 32 bits of our big integer. And so if we do something like this, I keep typing git for some reason. in my code here today. I guess it must be on the mind. All right, so BigInt, we'll call it large big. And we're going to initialize this with 0, 1 in an initializer list. And this is saying that the first 32 bits are 0, and then the 32nd bit is going to be a 1. That is, our big integer is going to be 1 to the 32nd power. Okay? And then we'll say std string large big digits is equal to large big dot to string, and we'll say if s2l large big digits is not equal to 1 u long long shift left 32, return false. Let's add another message here. Failure. Unexpected value converting large. Well, it's a little bit weird to say large BigInt. We'll just use the same error message. It's fine. Okay, so this is just taking the digits that we got when converting this to a string, converting it back to a 64-bit integer using this S to L, and then comparing it to this value here, 1 to the 32nd, or excuse me, 2 to the 32nd power. Okay. So another test that I would like to do is to make sure that that exception handling or exception throwing capability is working as expected. So let's say try, and we're going to say BigInt. Let's see, we'll say bad init, and it's going to be 1, 2, 3, 4, Q, 5, 6, 7. So this should not convert cleanly to an integer. It should throw an exception, which we will then catch. So we're going to say catch, and it's going to be const std invalid argument. Yes. Invalid argument reference error. And we need to record that the exception was caught as expected. So we'll say bool caught exception equals false. And then here we'll say caught exception equals true. And then we'll say if not caught exception, printf failure, exception not caught for bad BigInt initialization. Return false. Okay, so there are a few more cases, 2 in particular, that I would like to test, and those have to do with initializing the big integer with either to 0 or converting it to a string from 0. And so let's start off by saying BigInt 0, and we're just going to initialize that like this. And so then we'll just say std string 0 str equals 0.to string. And then we'll say if s to I of 0 stir is not equal to 0, printf failure, unexpected value, converting 0 string or 0 BigInt to string. And return false. Okay. And then there is just one last case that I would like to look at, and that's if we initialize a big integer with an empty string. So we'll say empty, and we'll say std string. Actually, no, we can just say this. We can just say this. If empty is not equal to 0, it's funny, as I'm writing these tests, I just thought of something that we almost certainly are doing incorrectly in our toString function. I think the compiler might catch it for us, but let's see. Okay, so we'll say if empty is not equal to 0, printf failure unexpected value, initializing BigInt with empty string. Return false. And then down here we'll say return true. Okay, so let's go back to our shell for a moment and see what happens if we try to build our big integer class. Okay, and yes, I think this is actually this is maybe not quite the failure that I was expecting, but in any case, let's go back to BigInt.c. And the problem with this approach is that this div mod modifies our big integer. What we need to do is say something like, I suppose we can do that after 0. We can say BigInt copy is equal to star this. Because converting to a string is a destructive process, because we have to divide by 10 repeatedly and take the remainder, and that destroys the original big integer. So we need to make a copy, and then we can say over here copy.divmod, and here copy.0. Now, one thing that threw me off looking at the error messages here is it seems to be complaining about the initial call up here to 0 also, which suggests to me that maybe there is a mistake in our header file here, because this 0 function, I believe this should be declared as const. And let me just see, is there any particular reason why that is not the case? No, none of this should modify anything, and so we should be able to go down here and say const and go back to the header file. And you don't have to necessarily be obsessive about const correctness, but it can help you find mistakes like the one that we just ran into. If I hadn't thought of it, the compiler would have reminded us, going back to our toString function, the compiler would have reminded us that, hey, you're modifying the original big integer, even though with this const, you promised that you weren't going to. And so a const can help you find some mistakes. Okay, so I think this is going to be more acceptable to the compiler, so let's see about that. Okay, that seems to be good. So now let's go over to our tests directory and try building that. There also seem to be some problems here. Let's see. unexpected unqualified ID before, oh, expected unqualified ID. That's not what I expected. Let me just make sure that I let me bring up the, it should be std invalid argument. I think there were some examples in here. I think that should be fine. Did I think I included this std except. Let me just check on that. Yes, std except is up there at the top. And that's right. Right, because I'm including it in the CPP here, it's not going to be accessible in the test here unless I go up and do something similar up here where I say include std except. It was the error messages seem to be suggesting that I can't make that constant, but I'm pretty sure that that's not the case. I made some typos, so let's fix those also. Let's see, yeah, this one here. Okay, so now let's run our BigInt test. And it's stuck in an infinite loop. Well, not quite infinite. It turns out that I was messing around with this before I started recording and found this bug. It turns out that this is actually a bug in the original BigInt implementation. It has nothing to do with our new code. And I thought about going through the whole process of showing you how to debug this and such, but it's not actually that interesting. And so I'm going to cut right to the chase. If we go to our BigInt implementation and we go to compare, if you look carefully at this code, you may notice that size is an unsigned value. And here we are subtracting 1 from size. And so if both of the big integers that we are comparing are empty, they have size 0, then we will get stuck in not an infinite loop, but maybe a very long loop right here, because this will end up as the max unsigned integer instead of as something like -1. And so the way that we can fix this is just to say if size equals 0, return 0. So for this function, the return value just indicates what the result of the comparison was. So -1 indicates that the first was smaller, +1 indicates that the second was greater, and 0 indicates that they were the same. And so we just need to return 0 right here. And if we go back to our shell and go to our big integer class and go back to our tests and make and run our test, and we have success. Now, I always like to do a sanity check when I see my tests passing well, I guess in this case it wasn't on the first try, but very quickly, just to make sure that everything is working as expected. What happens if we go here and we don't catch this exception here? Let's just make sure that we're actually throwing this exception as we expect. And then presumably that we're also running all of the other tests. So let's go back here and we will make and run. And we see that it does throw our exception. So that is definitely working as intended. Okay, so it might be perhaps a little bit anticlimactic, but that brings us to the end of this video. In the next video, we'll be taking a look most likely at problem number 55. And then at some point in the next few days, I'm hoping to have problem 54 ready to go, which involves poker hands and writing a program to determine the winner of a poker hand. So that should be a lot of fun. Keep an eye out for that.